What are complex numbers? In 3 minutes. To form complex numbers, we use the number sets that we're already familiar with. Let's take a look. 0 and a positive number line. The positive whole numbers, 1, 2, 3, 4, and so on, are called the natural numbers, double struck n. If we extend the number line backwards, we can add the negative whole numbers too. All these form our integers, double struck z. Inside this number line, we can also find our rational numbers, fractions, such as -5/2, and irrational numbers, numbers which cannot be expressed as fractions, such as e and pi. Altogether, these numbers are the real numbers, double struck r, so we can label this line RE, like so. This is one part of forming complex numbers. For our other part, we need imaginary numbers. We can represent this using a vertical line, the top for positive numbers and the bottom for negative numbers, labelled IM. Now, both axes have the same numbers, so what's the difference? The imaginary axis uses the imaginary unit, I, which is equal to the square root of -1. This means when we read 1 on the imaginary axis, we actually read 1i, 1 lots of the square root of -1. Or when we read -3, we actually read -3i, -3 lots of the square root of -1. Putting the real and imaginary parts together gives us our complex number, in the form x plus yi. X is a real number from the real horizontal axis, and yi is an imaginary number from the imaginary vertical axis. Here's an example. Let's find the value of this complex number, at position 3, 2 on the axis. As the number is 3 across on the real axis, 3 is our x. As the number is 2 up in the imaginary axis, 2i is our yi. Our complex number is 3 plus 2i. And that's the introduction to complex numbers, x plus yi, where I, the imaginary unit, is the square root of -1. An introduction, however, wouldn't be complete without covering its uses. Where are complex numbers used? Apart from the classic solving equations with no real roots, they're used practically in a wide range of fields, where real numbers alone can't suffice, producing elegant mathematical fractals like the Mandelbrot set here, analysing aircraft stability for control systems, and even in quantum computing for quantum computing gates. Continuing this video series on complex numbers, and with a brand new upcoming quantum computing series, the foundation, logic, and implementation, Be the Calculator will expand your mathematical toolkit and problem-solving prowess, one video at a time. Thanks for watching.